All right, welcome back to the discussion for section 2.1. So there was a couple of questions asked. Let's start with number 10. Number 10 is kind of a long one. I may have to erase my board more than once in order to do this, but here we go. 10 asks you to find f of a plus h, and then the difference quotient f of a plus h minus f of a divided by h. This will become more important as you get into calculus. You'll see this pop up and we start to define a certain mathematical principle called the derivative by this, but this is called the difference quotient. And we're doing this all in relation to the function f of x equals 3x squared plus 5x minus 2. So these first two, f of a and f of a plus h, they should be easy, because f of a is just plugging in a for my x's. So that is 3a squared plus 5a minus 2. And they simply ask you for the coefficients in the answers. So for this part you would put 3, 5, and negative 2. F of a plus h gets a little bit bigger and hairier. So I'm actually going to delete or erase this bottom part and we'll come back to it. F of a plus h is plugging in a plus h in place of my x's. So that is 3 times a plus h squared plus 5 times a plus h minus 2. And I'll want to expand this because the answer is looking for all of the coefficients in front of, say, the a squared terms, the h squared terms, and all of that. So take this a plus h and square it. I won't show the work here. Do this on your own or on a piece of paper if you can't just jump from here to what I'm going to write. But this becomes a squared plus 2ah plus h squared when I square a plus h, right? And I can distribute, so I have plus 5a plus 5h, and then still this minus 2. And then distribute your 3, so that becomes 3a squared plus 6ah plus h squared plus 5a plus 5h minus 2. And again, they're looking for the coefficients in this, so you're looking at 3, 6, 1, 5, 5, and negative 2. Make sure that you put these in the right order. If it's listed, a squared, ah, h squared, make sure those terms line up with the answer that you're putting in. Right? Now I'm going to use both of these because this is f of a plus h. And this is f of a. Right? In the difference quotient, they're asking us to do this. They're asking us to put f of a plus h minus f of a all over h. Right? But f of a plus h is this, right? And f of a is this, so that is to say I have this expression. I have to write it kind of small here. I hope you can still see it. If not, I'm going to rewrite this up at the top in a minute, but it's f of a plus h minus f of a. So minus, and then putting into parentheses the whole expression f of a, which was 3a squared plus 5a minus 2, right? There we go. That's better, it looks like. Okay. So I have f of a, all of this, or f of a plus h was all of this junk, and I'm subtracting off f of a, right? And then this entire thing is over an h. I'm going to erase this top part, so if you need to write any more of it down, pause it, because here it goes. I'll take this and rewrite it up on the top so I've got that space to work. Alright, so I'm not concerned with this left-hand side anymore, that's just the expression that gave us this. So this turns into this 3a squared plus 6ah plus h squared plus 5a plus 5h minus 2, and then I'll distribute this so I get minus 3a squared minus 5a and then plus 2, and this is all over h still. Now it's big and it's ugly, it takes up the entirety of this board, right? But the nice thing is that when we're dealing with polynomials, as long as my f of x is a polynomial, anything up here that doesn't have an h is going to end up canceling out. This 3a squared cancels out with a minus 3a squared. The 5a cancels out with a minus 5a, and then minus 2 cancels out with a plus 2. Right? So the only things I have left are this 6ah plus h squared plus 5h, and that's it, all over h, right? And since everything in the numerator has an h in it, that means I can factor out an h, right? So this becomes h factored out leaves me with a 6a plus an h plus 5. And this is all over h, but now I have a factor of h in the numerator and a factor of h in the denominator. Those will cancel. And so I'm then left with 6a plus h plus 5. So again, the final answer is looking for the coefficients, 6, 1, and 5. If there's any h squares, I don't have it in front of me so I can't see, but if there's any h squares, those coefficients are 0. If there's any a squares, those coefficients are 0. That's it. It's just these numbers. All right, good. All right, let's look at number 12. Number 12 asks you to find the domain of a function f of x is x plus 1 over x squared minus 4, right? So we're looking for issues, right? I have issues if my denominator is 0. That's where I run into issues here. And so that's really all I have to say here is my domain issue is this denominator x squared minus 4 cannot be 0. Right? But know that x squared minus 4 is x plus 2 and x minus 2 as factors. So if this can't be 0, then x plus 2 can't be 0, otherwise the product here is 0. And x minus 2 can't be 0, right? So I should get, out of x plus 2 can't be 0, which is to say x can't be negative 2 if I subtract 2 from both sides. And similarly, I'll get x cannot be a 2, right? And so then my domain is that it can be anything. This numerator doesn't matter, because if the numerator is 0, who cares? The whole thing is just 0. That's fine. But I just can't have zeros in the denominator. So my domain is simply x can't be negative 2 and x can't be 2, which is to say if you were to put it in interval notation, any number between negative infinity and negative 2, excluding negative 2, but union that with the numbers between negative 2 and 2, and union that with the numbers from 2 to infinity, that's my domain, right, in interval notation. Let's look at number 13. 13 is also asking for the domain, but we have a different function. We have the square root of 4 minus 9x, right? And the issue here is that we have this square root, and I can't take the square root of a negative number, right? So that is to say, whatever's under this 4 minus 9x, it has to be greater than or equal to 0. That's the issue, right? If it's less than 0, we have a problem. If it is 0, it's fine because the square root of 0 is 0, but the square root of any positive number is okay. So we have whatever's under the square root simply has to be greater than 0. And so I'll solve. I can start by subtracting 4. That leaves me with negative 9x is greater than or equal to negative 4. And if I divide by negative 9, remember we're dividing an inequality by a negative, and so that flips the sign. And now it's x is less than or equal to. The negatives cancel out, so I have 4 9ths, right? So this is my domain. I don't recall how they want the answers. If it's in interval notation, it is negative infinity up to and including 4 over 9, so it's a bracket. Right? And that's our domain of this problem. All right, and then the last one was the most requested one. It's number 14. So number 14 also is a domain problem, but here I have the square root of x over 8x squared plus 7x and then minus 1. And it's noteworthy to say that this denominator can be factored. I'm going to rewrite this as the square root of x over, and this factors to 8x minus 1 times x plus 1. Okay? All right. So I've got two issues. Well, I've got three issues really, but I've got two categories of issues, and the first is that I have a square root. Right? It's in the numerator, but it's still a square root, so it matters. So I have whatever's under that square root, which is just x, has to be greater than or equal to 0. There's nothing left to solve here, it's already solved. So my numbers are limited already to 0 and above. Right? And then my denominators, the denominator can't be 0, so that is to say 8x minus 1 can't be 0. And I also have to satisfy x plus 1 can't be 0. Right? I have to satisfy all three of these. Right? These are ands. Whenever you have domain issues, they are and issues where I have to satisfy this and this and this. Right? So on this first one, if I add 1 to both sides, that gives me 8x can't be equal to 1, and if I divide 8, then I have x can't be 1/8, right? On the other one, if I subtract 1, I get x can't be equal to negative 1, but it already can't be negative 1 because x has to be greater than or equal to 0, right? So this guy doesn't give us any more information. This is just one very specific value it can't be, which is already in an ocean of values that it can't be, right? X has to be positive, and it also can't be this particular negative number. But that's redundant. This doesn't matter, right? So this, I don't care. It's already taken care of here. This, though, with this x can't equal 1/8, that is one of these numbers that is positive. So really, I'm looking at 0 with a closed-in circle, because it can be. And then there's this one spot where I have an issue, so I put an open circle, and it can be up to it or beyond it, but it can't be it, right? And so in interval notation, I would have 0 in a bracket, up to 1/8 in a parenthesis, and I would union that with the numbers between 1/8 and off to infinity. And that should be our solution for number 14. Thank you guys, and I will see you for section 2.2 in just a minute.